And I want to address that in a little bit more general way. I take the angular momentum and I choose a point Q, and I know that the definition is position vector relative to point Q cross P. I take the derivative, time derivative, dl dt, relative to that point Q. It's always important that you state which point you have chosen relative to which you take the angular momentum. That is going to be Vr dt, excuse me, cross P plus R of Q cross dp dt. This is the way that you take the time derivative of a cross product. We calculate the angular momentum relative to point Q. So the index has to be Q throughout the equation. The position vector is relative to point Q. And in this equation, you see the correct index Q here, you see the correct index Q here, but I slipped up here and I put a C there. There is no C in this problem, so this is also R of Q. Sorry for that. This here is the velocity of the object, the velocity vector, which is always in the same direction as P. So this is 0. dp dt, that is the force on the object. We've seen that before in 801. And so now we have that dl dt relative to a point Q equals the position vector R from that point cross F. And this now is what we call torque. And we write for that the symbol tau. It is a vector. And I put in that Q again. And this is one of the most important equations that will stay with us for at least 5 lectures. What this is telling you is that if there is a torque on an object, the angular momentum must be changing in time. If there is no torque on the object, angular momentum will be conserved. And now you get some insight into this situation that we just discussed. The force, the attractive force, gravitational force exerted on the Earth is in this direction. The position vector is in this direction. So R cross F is 0. There is no torque relative to this point C, because the angle between the two vectors is 180 degrees, and so the sine of the angle is 0. Therefore, no matter where you are on the circle, always R cross F will be 0. There is no torque relative to point C. But if you take point Q, or you take here some point A, clearly there is going to be a torque, a changing torque even. And so there you will have a change of angular momentum. So there's something very special about that point C. And I will come back to that, of course.